So, are you ready? A population is a set of similar items or events which we will refer to as subjects. A set of similar items or events which we will refer to as subjects, which are of some interest for some question or experiment. If the question was, how effectively do Miss Rice's students learn, then the population would be the students in all my classes. If the question is, how effective is Eno River at preparing kids for college, then the population would be all of the students at the high school who are going into college. Does that make sense? If the question is, what colors of hair do women have at Eno River, then it would be all the girls at Eno River. The population can change based on what you're studying. It's like who you're talking about. Okay. And a population is considered to be the entire group of what I'm talking about. So if I'm talking about how many people are over 6 feet tall in the entire world, then all the people in the world would be my population. If I'm talking about what's the average height in the state of North Carolina, then I'm talking about just people in North Carolina. So the population can change based on who you're talking about. Okay. Bias is favoring some types of subjects. So this would probably be opinions over others. So bias can show up when you ask the question, or bias can show up in who you ask the question. So if you say the question like, isn't Miss Rice the best teacher ever? That's a biased question because I'm already telling you what I think as I ask the question. Does that make sense? Or if I ask a bunch of high school seniors, how much homework should we have? There's going to be some bias there because senior and you have arthritis and you don't want to be at school anymore. Does that make sense? Okay. All right. So when you take samples, there are 6 different common sampling methods, and the way this will show up on like the EOC or the way you'll lift this in like a question format is they're going to give you a situation, and then you're going to say, oh, that's like that type of sample. Does that make sense? So this is like multiple choice answer, so they'll give you a scenario, you come up with the type of sampling method it is. So a simple sample is where all individuals in the population have the same probability of being selected, and all groups of the sample size have the same probability of being selected. So let's say if I was to take, let's say all of the groups in here were groups of 3, and I took one person from each group. Does that make sense? So everyone has the same chance of being selected. But if I decide to only take 3 girls, then not everyone has the same chance of being selected because we got some boys in here. Does that make sense? Or if I take one from each gender, even then that's not the same chance because we don't have an even amount of girls versus boys. Does that make sense? Okay. The next one is a stratified random sample where the researcher wants to target an entire population but breaks them up into subgroups and then randomly selects the subjects proportionally from different subgroups. So that could be like we're trying to get some information about Eno River as an entire school, and so we check with a few people in each of the individual classrooms. And that gives us kind of like a pulse check of the entire population. Okay. The third one is a systematic random sample. So I'm going to check with every third person. I'm going to line everybody in the whole school up, and every third person I'm going to ask this question of. So still pretty random, but it's systematic. 4 is a convenient sample. Subjects are taken from a group that is conveniently accessible to the researcher. So maybe you were asking like, how much homework does everyone have each night? And you're trying to get something representative of the school, and you just ask everybody in this room. Convenient, but is it necessarily a great representation of the whole school? No, you guys are in an honors class, you're mostly upper level, like you're going to have a different homework load than a freshman taking Math 1, right? So you can get some information from it, but is it a good representation? Probably not. Definitely biased, yeah. Number 5 is a cluster sample. The entire population is divided into groups or clusters, and a random sample of these clusters are selected. All the individuals in the cluster are included in the sample. So a good example of this is at one of my old schools, they used to bring in like the drug dogs periodically. And the drug dogs wouldn't go to every single classroom. They would pick randomly like 5 classrooms, and the drug dogs went into that classroom and sniffed everybody.
What if they're not in there?
Yeah, well, that's the random check, and they don't have time to check everyone, so they just check in those rooms, and then they pull people that points out, and then. I mean, they checked my honors pre-cal, and they pulled 3 students, so. So maybe it does. Maybe it does. Yeah. All right, and then the last one is a voluntary response. This is like I'm on People Magazine's website, and they're asking my opinion about short hair versus long hair, and so I click a button that says I prefer short hair. Is that representative of the population? No, probably not. So those are inherently pretty biased because you're getting people who volunteer information, and people who volunteer information typically have some sort of interest in the subject, whether it be positive or negative. Voluntary response is actually how reviews work, right? When you're looking for a restaurant on Yelp or whatever, you're going to get people who really love it and people who really hate it, and anyone who's in between is probably not really writing a whole lot, right? Voluntary response. Okay, so those are the different ways you can get samples of things, and when we practice today, we're just going to look at some scenarios, and then we're going to say what type of sampling we think it is, okay? Random interrogation. Yeah, except they can just hang up on you, so that's still a voluntary response. Yeah. I would have to make it. Alright. I could look it up. Maybe if I can find one. Alright, so there are 3 different methods of data collection we have. One is studies, an observational study.
Why did you teach us this in this class?
Statistics, when you get into college and there's like tons of classes for everything, statistics is considered to be its own subject. So there's like English, history, math, statistics, science, like it's actually its own separate category. But in high school, we only have like the basic statistics stuff, and since it has math involved in it, they put it in math. Just like lower level, you learn like logic and reasoning, like inductive reasoning, deductive reasoning. Did that ever? Maybe it's switched out. It used to be in like geometry. It's possible that it might be in discrete, which we don't offer here, but put in a math class just because it most closely fits math. There's some mathematical elements to it. Yeah. So an observational study is one where the researcher observes, but they don't interact with the people that are the subjects. They might say give everybody the exact same something, but there's no control group. You just sit back and they watch what happens. Kind of like National Geographic, yeah. So we might have put all the animals in the same zoo, so we have messed with them a little bit, but other than that, we just sit back and watch. Or we might give all the people in the classroom the same exercise program, but after that, we sit back and watch. Does that make sense? Okay. The next one is an experiment. And an experiment is where the researcher is going to influence the subject and then observe the effect. You're definitely going to have a control group with this. Some people who don't get whatever it is, and then some people who do, to see what the effect is that specific thing. Medicine is really common, but also it could be other things. Sleep studies, stuff. All right. Another method of getting data is to do a survey, which is a questionnaire or an interview. Yeah, where you just fill out. You guys, those of you who did the pre-ACT, I think at this point most of you have probably done it. The pre-ACT has a questionnaire at the very beginning about all sorts of stuff about your parents and their education and how many classes have you taken and where are you from and all sorts of demographic information. They're collecting data just to see students and their preparation and how the United States compares to other countries and all sorts of stuff. Who is likely to want to go to what college, who's interested in what, all that stuff. A simulation is one you might not have heard of. I feel like this is probably not as common, but a simulation is a way to model random events, not randoms, random events. And simulated outcomes. Oh gosh. Simulated. My eraser's real good. Closely match real world outcomes. So you'll see people simulate. They could use a random number generator on a calculator or a website. They could flip a coin if something has a 50-50 chance. They could use a deck of cards if you've got a 1 in 4 chance or something like that. So there's all sorts of different ways you could do a simulation. One of the big things about statistics is, and this is something that you see in statistics a lot, is people will give you some information and then they'll make some sort of assumption. Because we've done this research, we can assume that this is true. And for anyone who is a statistics or has taken statistics classes from a teacher who's really passionate about it, the big thing they say all the time is that correlation is not causation, which means that just because you notice that something might be true in a lot of cases does not mean that that thing caused it. So if I notice a lot of girls have their ears pierced, that does not mean that being a girl caused you to have pierced ears, right? A lot of girls choose to have pierced ears. It might be a cultural thing, but just because you were born as a girl does not mean you're automatically going to have pierced ears in your life. Does that make sense? There's a correlation. There's not a cause. It's not something that made it happen. Okay, so that's something that we learn in statistics is when we study this stuff, we might notice some correlations, but we can't say anything is the cause. And I think one of the reasons for that is you look at how you can get samples and how you can get data, and you start to realize that there's a lot of ways you can do a bad job of that and find information that's probably not necessarily true. Does that make sense? I'm saying, like, we've looked at this and we've realized that a lot of these are probably not ideal situations, right? And we're probably not getting perfect information every time. And so that's why when we do statistics, we learn information, but we don't necessarily find causes to things. So we can notice there's some patterns and things, we can notice similarities, but it's a big leap to say, oh, that definitely caused that. That's a dangerous thing to do. Yeah, definitely not then. It's, I've noticed this. So maybe. Yeah. Okay. So there are 3 different assignments in the packet. If you look, you can see 3 different ones. So the first one is about sampling bias, which means that the way that you're getting your sample is a biased way of getting that sample. So they want you to read through the scenario and determine whether or not there's bias, and there basically is in almost every single one of these. And then after that, they want to say, like, well, what is the bias? What's the source of the bias? So if I say, isn't Miss Rice awesome? Then I'm phrasing a question where I'm giving my view to the person, and that's what's creating the bias, is that I'm suggesting what their opinion should be. That makes the bias happen. So you're going to identify what part of this sampling method makes it so there's a bias. Okay? So maybe I'm doing a study and I'm asking if math is a subject that should be taught in schools. And I ask you guys, I'm asking an upper level math class if math should be taught in schools, and you guys are probably going to be mostly in favor of it because you're in upper level math and that's something you're good at, right? If I ask a math 1 class, should math be taught in schools? Maybe not as many kids saying yes. Does that make sense? So I'm asking, instead of asking a group of like people who are good at math and people who are bad at math, like all sorts of people, I'm asking like a group of kids who are good at math, and that's a bias because I'm going to get a certain type of result from that. Does that make sense? So I would say the better thing to do would be to ask all the kids in the school. Should math be taught in school? That way you're asking the entire population, not just people who are good at math.
So the source of the bias would be
yeah.
the people who are good at math.
Right.
Okay.
If I'm trying to figure out what sport is the best and I ask a soccer team,
okay, yeah.
that's biased, right? They're probably going to say soccer. Yeah, that doesn't make a lot of sense, right? Okay. So you're going to say who has the bias, like what the bias is, and then you're going to say what they should have done instead to get a better sample. Okay. So the first one says, a company is interested in opening a gym on its premises for all employees. The company has 3 shifts, morning, evening, and late night. They asked the first 25 people reporting to work during the morning shift and the evening shift if they would like to use the gym and what hours they would like the gym to be open. Okay, so discuss in your groups, biased, unbiased, who's it biased for, what should have been done instead.
Because they're only asking the morning and evening shifts, that should be open.
You would say like, you could phrase it either way. You could say it's biased because the people who had the late night shift didn't get any sort of influence, you know what I'm saying? Or you could say it's biased towards these people because they did get to say what they wanted. Yeah, today you're going to have your hands stretched out because we got a lot of writing today. Okay, so what kind of biases are you guys noticing in how they took the sample? They didn't ask the late shift people. So they asked nobody working graveyard, that's a bias. Is there any other bias you see in there? Yeah, the first 25 people. How could the first 25 people give some bias?
Because they're really on time.
Yeah, you're asking punctual people when they would like the gym, that's probably different than your people who are chronically late, isn't it? It's probably a different time. So the bias is that they're talking to people who are punctual and they're talking to people who only have 2 shifts out of the 3. So what's a way that you could fix that and make it a more fair sample? Yeah.
Ask all shifts and everyone who comes in the door can get some votes, even, and just
Yeah.
the average out of that. I mean, they can sample the better.
Right. And that's what you run into with statistics is, of course, the best information would be if you got everyone to answer your question, every single person. But but that's like you can't always get every single person, and then typically the person who's doing the asking is getting paid, and that can get really expensive when you have one person doing hours and hours, right? So there's always a balance between like what's practical and what needs to happen to make it a fair representation. So we're probably not going to be able to ask everyone who walks in the door, but what could we do that would be better than the first 25 people?
Maybe to do it for every single shift and ask maybe the first 50 people, because that seems like a good number.
But you're still not getting 50 people.
Well, how many people would it
It's 25 from each shift, but throughout the whole shift.
Yeah, so you could still do 25 from the shift, but don't do it all from the beginning. Do like the first 2 people who walk in and then wait a little bit and then 2 more people and then wait a little bit and 2 more people. Make sure you get the last 2 people who walk in because their opinion matters too. Okay. So I'm not going to write that again because I already have it written on my answer key, but write something to that effect. Does that make sense as far as what the instructions are asking for? Okay. So go ahead and work on that. Take your time. Enjoy it. Are you guys ready? Okay. So, yeah, do you like that? Because you're like shooting.
Whoa, that's inappropriate.
It's like the different sampling methods. Got that one. No? Okay. Yeah, exactly. All right. Every 5th person boarding a plane is searched. What would that be?
5? No, that would be the thing.
Systematic. You're selecting a random number and then you're doing every nth individual for that. So that would be systematic. At a local community college, 5 math classes are randomly selected out of 20, and all of the students from each class are interviewed. Is it proportional or is it... So we said stratified random, which has subgroups, and then subjects are chosen proportionally from the subgroups. Or we have cluster, where you have groups again, but when you have the cluster, every person is included. So all the people. Yep. All right. Does that make sense how you're doing these? Okay. So when you get to the point where you're ready to check them, the answers are on the back wall. The last page is just saying whether something is an observational study or an experiment. So the big thing that you're looking for, that's the difference between them, is it's an experiment if you're going to have a control group and are measuring cause and effect. It's an observational study if everybody's given something and you're just watching. So the big thing to look out for is whether or not there's a control group. Okay? All right.
Okay.